Today, we're gonna speedrun building a combat robot. This run is going to be hand tools %, meaning the only tools available are those that can be commonly found. The minimum requirement for a combat robot is that it has to be able to move and it has to have a weapon on it. So right off the bat, I go straight into cutting down some acrylic and foam core, which will form the base of our chassis. Since I don't have the ability to design and 3D print my robot for this speedrun category, I have to make do with the materials that are easily manipulated, but are also strong enough that they don't self-destruct when I attach a weapon on it. So right now I'm stacking my pieces of acrylic onto the foam core. This will make the foam core more rigid, while still giving me a decent amount of thickness. I then clamp my material and prepare to drill it with holes where I will then attach my weapon motor. The black disc on the table that you'll see me using in a second is a stencil for drilling. It allows me to have an easier time aligning and then drilling my holes. For reference, the motor that I will be attaching to this will be a small brushless motor that has a screw on it, so I can just directly attach my weapon to it without needing to worry about belts or anything. I go back to my main workstation and unpackage my motor brackets. After I move them around a little bit to figure out where they would go on my robot, I realized that my robot was just way too long. So I'm just gonna go ahead and score it and cut it down and then snap it in half to make things a little easier for myself. I do struggle with this a little bit because it is 2 layers, but I'm eventually able to get it. Over here, I begin to mark my holes for where the drive motors are going to be, so then I can go back to drilling the holes. My entire chassis is really not that complicated. It will be mainly just that sheet of acrylic, and once we attach all the motors, pretty much half the robot will be done at that point. Remember, the goal is to make a robot as quickly as possible with mostly hand tools, so using weak materials is fine in this situation, as this robot only needs to be able to hold up to its own power and its own weapon. So right here, I had a little bit of a time loss as I was fumbling around with my drive motor brackets, and I realized that the fasteners that I had just weren't long enough to go through both the stack of acrylic and foam core. So I went ahead and just cut down the foam core in the location where the motor brackets went. After I fixed my mistake, I was able to easily attach my motor brackets back to my robot. So actually right now what happened is someone walked in, because I was doing this in the kitchen of where I was staying, and they started talking to me, so I spent a little bit of time just chatting with them while trying to be as efficient as possible at the same time. After that, I just screwed my weapon motor onto my robot. So you can see here that my robot kind of just looks like a square, and I didn't really like that, so I started cutting down the corners so it looked a little bit better. Usually for a lot of combat robots, there would be at least 3 points of contact, generally 2 wheels and a piece of metal that would glide along the floor. In my case, to save time, I didn't do anything like that. So there would be 2 wheels, and the 3rd point of contact would just be the front foam core of the robot. Currently, I'm messing with my weapon stack. My weapon is just a random piece of steel that has a hole in the center of it. I needed to put it onto my motor. The heights didn't work out, so I tossed some washers and spacers on it until it did. It took me a little while to figure out what order they were supposed to be, and I kept disassembling and reassembling it, but eventually I was able to get it, even though I wasted a little bit of time doing so. Right there, you know I gotta give it a little spin. Pretty much the entirety of the body of the robot is complete, and what has to happen now are all the electronics and all the soldering that has to be done. Currently, I'm soldering connectors onto my drive motors so that I'll be able to connect it to my speed controllers later on. The electronics on a combat robot really aren't that difficult, and it largely is just a glorified RC car. What needs to go on it are the motors, of course, then the radio receiver, which allows you to control it from a distance, then the speed controllers for the drive motors, which takes the wireless signals and tells your motors what to do. The speed controller for your weapon is also necessary as it tells your weapon motor to spin. After that, you need to figure out a way to plug in your battery and make sure everything gets the right amount of power. A healthy dose of hot glue usually helps to keep all of your electronic components in place as well. The soldering for the speed controllers is a little more difficult than just soldering in connectors, as I need to make sure that the components get the right amount of power. What I have to do is solder the power of the weapon speed controller and connect that to the power of the drive speed controllers, so that I don't need to power them separately with like 2 batteries or something. You might notice that there is smoke coming out from doing all the soldering. This is usually a bad thing, as I would end up inhaling all of the fumes. Personally though, I'm built different, so I just don't worry about it. Wire management isn't really my strong suit, so as a little crutch, I just hot glue all of my electronics down so things will stick together better. After that, I get ready to plug everything in and have all the electronics down and safe. But before that, I need to make a little way to encapsulate all of my electronics so that my weapon doesn't accidentally hit its own electronics and then explode itself. So that's what I'm doing right now. I'm cutting down foam core and then measuring to see if it fit, and then I'm going to cut down more foam core and repeat the process until I have a little box for all the electronics to hide inside of. My method for doing this is I go back and forth between my 2 stations and hot glue pieces down until things start to look a little bit better. This run really wasn't that efficient, and there's a lot of room for improvement. I feel like I could get a sub 30 minute if I just did things a little bit faster and had a little bit more planning going into this. I made a handful of mistakes through this run, which probably cost me somewhere between 5 and 10 minutes of time. Something I'd probably do a little different here is instead of creating my own foam core box, I'd use my packaging that came with all my electronics and stuff my electronics in there, and then probably just glue that down. It'd make things a lot faster and just about as safe as long as I jam enough hot glue everywhere. Yeah, you might notice that I use hot glue a lot, and hot glue is just the best for quickly making these things. I made a little error here where my weapon hits my foam core a little bit, so I just grabbed it and scraped it back and forth until it was able to spin freely. Pretty much everything has been wired up and has been built so far, so I was just about ready to plug everything in and do a small scale test. What I'm doing right now is I'm messing around with my receiver, which is the thing that allows me to control this wirelessly. I'm plugging all the electronics in, and you can hear a little beep when it turns on. I also need to set up my transmitter and get everything ready. After I bonded my transmitter to my receiver, I had to make sure all the settings were correct so that I'd be able to spin up my weapon and that my motors would be able to drive in the correct direction, so I'd be able to control it easier. So around this time, I realized that my weapon isn't spinning in the correct direction, so I do have to desolder and then resolder the electronic speed controller. This happens because my weapon can only spin in one direction because of the feature of my brushless motor. My weapon motor spins best in one direction because if it spun in the same direction of its screw threads, it would eventually unscrew its own weapon off. So I need to make sure it spins in the correct direction. Once I see that the motor jitters in the correct direction, I unplug it and then get ready for a full test of a full spin up and full drive test. So I hot glue the back plate on and get ready to bring it down. It's important to test these things safely as there's a lot of energy and these things are really dangerous. My way of testing this safely is I bring it to an area where there's not much that it can hit and I stand behind a glass door. After I do a little bit of preparation and hide behind the screen door, I'm able to see that the robot can definitely drive around and it can definitely spin up. So my run is complete at about 47 minutes, which puts me at the top of the leaderboards, mostly because the leaderboards don't exist yet. So thanks for watching.